Question 38. Compound X is an ester. Which acid and alcohol react together to form compound X? So in esterification, we know that there will be a carboxylic acid reacting with an alcohol. I will not draw the entire structure of the acid and the alcohol. Let's focus on the functional groups that are reacting. The carboxylic acid group during the reaction will lose the OH group, while the alcohol group during the reaction will lose the hydrogen atom. This forms the byproduct of water during esterification, and the remaining portion of the molecule will combine to form an ester bond. Specifically, this half comes from the carboxylic acid molecule, while this half comes from the ethanol molecule, and together forming an ester. So in compound X, we can cut the molecule here according to how we have done in this diagram, and this portion of the molecule will come from the acid, while the other half comes from the alcohol. So we need to match the structures in each of the options to the structure above. For the acid portion, option A does not match the acid that we have circled out above. Option B does match the acid that we have circled above. In the acid portion above, we see that the carbon atom next to the carboxylic acid group is bonded to one CH3, one CH3, and one CH2CH3 group. This is indeed the case. The carbon atom next to the carboxylic acid group in option B is bonded to one CH3, one CH3, and one CH3CH2 groups. Option C does not match the acid component in the ester. Option D does match the acid component, where the carbon next to the carboxylic acid group is bonded to a CH3, a CH3, and a CH2CH3 group. Let's compare the alcohol portions now. The alcohol in option A is too large. The alcohol in option B does match the alcohol above, where there is a central carbon that is bonded to 3 CH3 groups, and in the middle, a CH2 group before joining the hydroxyl group. Therefore, B is the correct answer. Option C is wrong because there should be a CH2 group between the hydroxyl group and the carbon group that is bonded to the many CH3 groups. And option D is also wrong because there is one additional CH2 group in the molecule. Therefore, B will be the correct answer for this question.